Hi guys, so in this video we're going to be looking at asymptotes, which feature on both the CIM and AdMath courses. So asymptotes are something to do with functions, and basically what they represent is like a line on the graph which the function should be able to touch and approaches but doesn't actually touch. So on the right I've drawn here the function f of x equals 1 over x, and the asymptote is in green. As we can see, the function, it keeps going closer and closer and closer to the green line, but it doesn't actually hit it. So it gets infinitesimally close. And that's why it's called an asymptote, when it actually gets so close but never reaches it. And there are mathematical ways of calculating what the asymptote is. In this case, the asymptote is y equals 0, which is actually just the x-axis. And that's the asymptote for 1 over x. The other asymptote, actually, if you might have noticed, is the y-axis, as this function tends towards negative infinity, but this side of the function tends towards positive infinity. So as we can see on both sides of these lines, for the horizontal asymptote, the x-coordinates tending towards negative and positive infinity on both sides, and vice versa on the vertical asymptote. So let's just start off, now that we've gotten what asymptotes are, by figuring out how to calculate them. So there are three types of asymptotes. There are horizontal, vertical, and oblique asymptotes. Horizontal and vertical asymptotes are pretty self-explanatory, but oblique asymptotes are actually lines and curves. So that gets more complicated, and you'll learn more about that. You won't learn that in the IGCSE course. You'll learn about that in future math courses. So let's start with horizontal. So horizontal asymptotes are like so. They are actually the harder ones to calculate, so we'll leave that till we get to vertical. So let's start with vertical first. So vertical asymptotes are vertical, and the way you can calculate them is quite simple. So let's say you had the function f of x is equal to 3x plus 4 divided by, let's say, x squared minus 7x plus 10. All right, so vertical asymptotes, basically, since they're vertical and the y coordinates are going towards infinity, what that means is that the denominator of the function has to equal 0, because the closer it is to 0, the bigger the number is, and therefore the closer to infinity. So what we do is we take the denominator and set it to 0. So we get x squared minus 7x plus 10 is equal to 0. And then in this case, we can factor it since it's a quadratic, and we get x minus 5 times x minus 2 is equal to 0. So x is equal to 2 and 5. So what that means is that at the points x equals 2 and x equals 5, so we have these lines over here, which are the asymptotes of the function. Okay, so that's how you do vertical asymptotes. Pretty easy. You just set the denominator to 0. So if the denominator was like 3x minus 6, then the asymptote would be 2. Now let's move on to horizontal asymptotes. So actually, these are more complicated in the way you approach them, because there are 3 different ways you can get asymptotes in the horizontal asymptote. So it's broken down into 3 categories. So we think of the numerator and denominator as having power. So for example, in this function over here, let me just erase all this working over here. Let me just erase that. So for example, in this function, f of x equals 3x plus 4 over x squared minus 7x plus 10, we say that the numerator has a highest degree of 1, because x to the power of 1 is the highest. X to the power of 1 is the highest value of x. Here, however, it's degree 2, because x squared is the highest one over here. So this is how we should be looking at the horizontal asymptotes, based on the numerator and denominator's degrees. Degrees of x, highest degrees of powers. So what we're going to do is start with if the numerator has a degree less than the denominator. So I'm going to write n equals numerator, d equals denominator. And these are all highest powers or degrees. So if the numerator is less than the denominator, then the asymptote is y is equal to 0. So that means that it would just be this horizontal asymptote. In this case, with 1 over x, we can see that the numerator has a degree of 0 and the denominator has a degree of 1. And therefore, since it's larger in the denominator, the asymptote is y equals 0. Let me just move this down because we need more room for that. All right. If n is equal to d, so that they have the same highest powers, the asymptote, so this will be, so let's say we had a function in the form ax squared plus bx plus c divided by dx squared plus ex plus f. So the asymptote would be a over d. It's the ratio of the highest powers. It's the numerator's ratio over the denominator on the highest power, the coefficients of the numerator and denominator on the x squared term. In this case, if it was x cubed, same thing. If they have the same highest power, then it's the coefficient of the highest power divided by each other. So it's a over d in this case. And if the numerator is greater than the denominator, then the asymptote does not exist. So I'm going to briefly explain why each of them are the way they are. So with horizontal asymptotes, the reason why the numerator, if the numerator is less than the denominator in terms of highest powers, the asymptote is going to be y equals 0, is because let's say you had x plus 3 over x to the power of 4 plus 4x squared plus 2. If you substitute a really big number into this function, you're going to get a numerator that's much smaller in comparison to the denominator. And as you input higher and higher numbers, this is going to grow much faster than the numerator, and therefore it's going to get much closer and closer to 0. So that's why that's the asymptote. If the powers are the same, well, let's think about 3x plus 4 over 5x plus 6. So essentially what they're saying is the y-intercepts don't matter, because if we do the same thing as we did for the last part, which was putting in really, really high numbers, we will see they'll only grow based on the coefficient, because this is what's ultimately causing its growth. If you think about it, this y-intercept is not adding to it, it's just adding 4. It's not going to add 4 times the number. Therefore, slowly these y-intercepts will become more and more irrelevant, and the coefficients of x in this case would become the relevant ones, and therefore you divide them. And for n is greater than d in terms of highest powers, the asymptote does not exist, because if you think about it, if you think about x to the power of 4 over 3, and you substitute a really high number into x to the power of 4, x to the power of 4 is going to be the one that grows really, really fast. 3 doesn't change at all. And therefore, the number is just going to keep growing. And therefore there is no asymptote, because it's just getting larger. It's not tending towards a specific value. So those are all the rules with asymptotes. Let's just go over a couple of examples. So I'm going to do 2 examples over here. Let's say our first one is 9x squared plus 3x plus 1 divided by 23x squared plus 23x squared. Actually, not 23, sorry. Let's do 16x squared minus 9. So find the asymptotes for that. And then b would be 6x plus 4 divided by, actually let's do 6 over 4x plus 7. So if we can find the asymptotes for those, I know the first one is harder, but I just gave 2 that I could think of. All right, so let's start off by doing b, because b is definitely the easier one here. So over here, we can see that 6 is lower than 4x plus 7 in terms of highest power. So therefore, we know y equals 0 is automatically an asymptote. Now, the vertical asymptote, we have to figure out how to make this equal to 0. So 4x plus 7 is equal to 0. So x is therefore going to equal negative 7 over 4. So these are our asymptotes. X equals negative 7 over 4 and y equals 0. And let's do this part A, because part A is the harder one. So let's start off with finding the horizontal asymptote. So these both have the same highest power of x with power of 2 for x. So therefore, we just divide their ratios. So 9/16 will be our horizontal one. So we get y equals 9/16 as one of them. Now, the other one is if we make this equal to 0, the denominator equal to 0, that will give us our horizontal ones. So 16x squared minus 9 is equal to 0. And we can actually factor this out, or we can rearrange, doesn't matter. So we get x squared is equal to 9/16. X is equal to plus minus 3/4. So here, we're going to have two asymptotes for the vertical one. So we're going to have vertical asymptote x equals 3/4 and vertical asymptote x equals negative 3/4. I don't know why asymptote is y equals 9/16. So actually, sometimes you might be asked to graph these things. You can use the GDC, but it's also a good idea just to know how these things come about. So, for example, if you know that y equals 9/16 is an asymptote, then you know that, let's just draw a coordinate plane down over here. Then you know this line's an asymptote. Let's say that's y equals 9/16. And then plus minus 3/4. Those two signs are, those two parts are asymptotes. And now you've divided into 6 regions, and you know that it's going to appear in three of those regions. So anyway, that's that for asymptotes. Thank you so much for watching this video. Leave a comment if you need any further help on it, but otherwise I will see you in the next one. Thanks.